Unit 6, Part 10. This is the last part. Okay, compare linear and exponential models. Okay, without graphing, or we don't need to graph. Tell whether each quantity is changing at a constant amount per unit interval. That means it's changing the same. You're adding something the same, right? Adding the same amount. At a constant percent year. At a constant percent per unit interval. Or either justify your reasoning. Okay, first one. A bank account started with $1,000 and earned $10 interest per month. So every month is $10. Every month $10. Every month $10. The bank then paid 2% interest on the account for the next 2 years. Okay, for the first 2 years. For the first 2 years, the change is 10% every month, right? So it's a constant, right? Constant changing. But then the second year, the changing is 2% interest. So it's different. The first one, the first 2 years, there's no percentage. If we want to calculate the percentage, okay, how do I do? Start with 1,000 and earn 10%, $10 interest per month for 2 years. This is at a constant rate, right? Per unit interval. So the first 2 years, we're going to write it like this. The first 2 years. The first 2 years is changing at a constant amount, a constant amount. But the next 2 years, okay, I'm going to change the color. So the next 2 years, constant percent, yeah? So the little difference is a constant amount, same $10, yeah? Every month. So it's a constant. Constant means non-changing, right? But the next 2 years, the bank then paid 2% interest on the account. So the next 2 years is a constant percent. So the percent is not changing. Every year, 2% interest, right? So one is a constant amount. The second is a constant percent. Okay, second question. Jinlu earns a bonus for each sale she makes. She earned 100 for the first sale, 150 for the second sale, 200 for the third sale, and go on. Okay, so the first is 100. And then add 50, we got 150. She got 150. And then add another 50, she got 200. So this is a constant change amount. And there's no percentage. So the conclusion is constant amount. So that's it. Not too hard. Okay, next, number 3. Use this information for 3 to 8. Okay, this information. Okay. A bank offers annual rate of 6% simple interest. Simple, that means you multiply by the 6% and then multiply how many years. Okay. Or 5% compound interest on its saving account. Suppose you have 10,000 to invest. Okay. So 10,000 is the initial value. Okay, number 3, express f of x, the value of your deposit after x years in the simple interest account, and the g of x, the value of your deposit after x years in the compound interest. Okay, so the first one, f of x is the investment after x years. So it's going to be 10,000. This is your principal, right? Principal, 10,000. Okay, this is, and then you're going to add the interest. The interest is 6%. 6% is 0.06, right? So 6%, so 1 to 10,000 times 0.06, oops, 0.06. This is the interest of 1 year. And then how many years? We're going to times x. If I simplify this function, it's going to be f of x equal to, let me put x into the front, like the first, right? So I need to figure out 10,000 times 0.06. This is going to be what? Going to 6. 1, 2, 3, 4, so 600. Each year, in fact, you make a 600 interest. Times how many years? X years, and then add your principal. So it's 10,000. 1, 2, 3. So that is for the simple interest. Now we're going to find out the compound. I'm going to use a different color. The compound g of x. Initial value 10,000. And we're going to, the compound interest is going to be a little simpler. In fact, the function. Okay, 5% compound interest. 5%, that's 0.05. So we're going to add plus 1 because it's growing. So 1.05 raised to the, how many years? We don't know. Just put x there. So this is the total amount at the interest after x years for compound. This is for simple interest. Okay, is either f of x or g of x is a linear function? Yes, f of x is at least linear. F of x, we have slope-intercept form, right? 600 times x. There's no x squared, no x exponent, and no divide by x. So a number multiplied by x and add a number. Yeah, f of x is linear. Exponential? Yeah. G of x is exponential. How can you tell? Because g of x, we have exponent, and x is the exponent. Okay, so it's an exponential function. Okay, number 5. Find the value of your deposit after 3 years in each account. After 3 years, which account is bigger? Is a better choice. Okay, let's figure out f of x first. F of x. So 3 years, that means 600 times 3 and then plus 10,000. The initial investment, right? 10,000. So this is what? So 600 times 3, that is 600 times 3, that's 1,800. 1,800 plus 10,000. So this equal to 11800. So 11,800, right? Dollar. Okay, what about g of x? So 10,000 times 1.05 raised to the How many years? 3 years, right? 3 years. Okay, 3 years. So I'm going to use calculator. Okay. 1.05 raised to the power of 3. This equal to 1.15, and then times 10,000. This equal to 11,576.25. Yeah. We don't need to write the, yeah, let's write it. 25 cents, right? So which one is better? Of course, the f of x is better, right? This is a 118. This is a 115. This one is better. This one is, so f of x is better, okay? This one is better. A little more money, right? But not for too long. Okay, find the value. Number 6. Find the value of your deposit after 20 years in each account. After 20 years, which account is better? Now we're going to just change x to 20. I'm going to rewrite like this. F of 20 equal to 600 times 20 years. And plus the initial investment. So 600 times 20 years, and then add 10,000. So the after 20 years is 22,000. Yeah. Okay. G of x 10,000 times 1.05 raised to the power of 20. I'm using calculator. 1.05 raised to the power of 20, and then times 10,000. This is going to equal 26. I'm using calculator. Okay, 265.32. So after 20 years, my second function is bigger. Look at 26,000. It's a 22, right? So g of x is better. Okay. Number 3, use a graphing calculator to determine the length of the time and the amount must be held for the two choices to be equally attractive. Round your answer to the nearest 10. This one, you can use decimal.com to graph it by yourself. We're not going to do it here. But for this two graph, there one is linear, like this, growing, and another is like this, something like this, growing. And at some time, at some years, you're going to make the amount of money in your bank account going to be the same, no matter which interest, which function. Okay, use a graphing calculator to find the year, find the solution. We're not going to do it here. We run out of room. Number 8, use the answer to write a statement and vice. Number 8, we're going to skip it. So you are going to use your graphing calculator to find out. Okay, that's it. So number 8, you're going to give your customer advice. So which investment plan? You're going to use a 5% compound interest or 6% simple interest. Okay? So as long as you do finish all the way to number 6, you're good. Unit 6 is finished.